welcome to our STEAM exploration series. We have a group of engineers with us today who are going to share a little bit about their job. Thank you so much for coming.
Hi, thank you, Dr. Rose, for having us. Hello, West Park Academy. We are very excited to be presenting for the STEAM Career Exploration. And I want to give a special shout out to Mr. Pineda for allowing us to do that. If any of you have him as a teacher, he used to be my grade school teacher as well. So maybe in the future you can be doing this as well, presenting here at school. So let's get started. Like Dr. Rose said, we're engineers. And I just wanted to show you what engineering is. You can be, as an engineer, it's not just math or science. There's a lot to it. You can be working for the government, be in the industry, or be a professor in education, or construction, similar to Gabe and I that will be presenting, but also consulting and a lot of the design implementation, kind of like our colleagues Patrick and Alex. So we are in the consulting at the bottom right. This is what all engineers look like. So a little bit about me. My name is Mike Hernandez. I am a Chicago Public School alum. I went to Lane Tech College Prep, and I went to Champaign-Urbana for a college where I studied civil engineering. The best advice I can give you as a student, I know you're still not before high school, but just focus on not too much being stressed out about getting an A, and focus more about just the love of education. The path to knowledge is much more valuable than trying to get the A or B. Study hard, just if not for the love of learning, but proving when you give a chance, you can lead and excel. A little bit about me, that's just an old, where I was very young in Lane Tech, the top right where I wasn't tall. I used to dance, just to show a little bit about me, and from Chicago. So some projects really cool that I'm working on is one that's here in Chicago, near downtown area. It's building a brand new road. It's untouched, and something really cool is that this green plot of land, in 1930, there used to be the old Chicago River that cut through there, where now it's just a land that's going to be developed. So just some really cool pictures on how it used to look, where you see a bunch of machinery breaking out an old bridge. And then we built a brand new bridge with a triangle design of a wall to the right. So how it started and how it's going. Here's another cool picture of building the brand new road. 20 plus people working on putting concrete, similar to where you drive on. And at the bottom is how it looks right now, where you can have cars, now a bike lane to ride your bikes, but then also on the outside, you can walk next to the bikers. And then another cool project in Chicago was building a brand new tunnel 100 feet underground. So it would rain a lot in the northwest side of Chicago and would flood thousands of families of homes. And there had to be a solution. So what the city of Chicago did was build a shortcut for the river to take on the water a mile down and then let it out into a different river. So a really cool fact to just gauge on how fast the water goes. When it's full and it's flowing super fast, it can fill in an Olympic-sized swimming pool in 37 seconds. So just think a big pool, just filling that up in half a minute. So this is sort of how the water comes in to the left, and then water comes out, sort of like just a big pipe. And here are some really cool pictures of, to the left is the water coming into the tunnel at full force. And at the right, it's how we built the tunnel inside. And I wanted to share you guys a really cool video of how the tunnel boring machine, similar to the first Incredibles movie, where at the very end the villain came out with the machine out of the ground. This is something what it looks like in real life. So that's we saw that at 10 p.m. waiting for the machine to hit at the Rock. It was really cool. So those are the projects I'm working on. Now I'm going to pass it on to my coworker Gabriel Garcia.
How's it going? I'm Gabriel Garcia. I'm a civil engineer as well. So I graduated though from Bradley University. It's a couple hours south in Peoria. Um, I concentrated in transportation more. Growing up, I was a little more interested in the trains and the highways and the cars. So that's sort of how I got into engineering a little bit. Um, my role at WSP is a little bit of the same as Mike. It's a construction engineer, but I'm a little more around trains. I think I'm a little more around, um, a little more just moving parts with trains and highways throughout the day. The best advice I would have for students, I think growing up for me, it was to always embrace math and science. It's not necessarily shying away from it. I think, you know, the math problems and the difficulty of multiplication or the PEMDAS situations that young students go through. um that multiplication and the division can always get difficult, but you don't want to shy away. You want to keep at it. You want to keep learning from the mistakes, because at the end of it all, when you know you get past that, difficult times of multiplication and division, and after that, probably some geometry and then calculus. The opportunities are going to be endless. There's going to be opportunities where you can work as as an engineer, like we were talking earlier, accountant, just different types of fields of work that are out there if you just keep at it with the math and the science. um, if you want to go into the projects that I'm working on, or that I'm a part of and able to contribute to, my biggest one is, like I said, I'm around more trains and moving parts, because our client that we're working with is CTA, which is Chicago Transit Authority. You guys have probably seen those all around Chicago, obviously, but they never stop, right? They're moving 24/7. I'm sure you guys hear them, a decent amount. I know I do, down my street. They never stop, right? So when you're building a 5-story building, or whether it's a electrical pole replacement, or a simple sewer pipe replacement, if it's on, above, near, or next to any types of CTA train tracks, that's sort of when we bring our expertise as engineers to sort of coordinate with, um, you know, like Mike said, just different parties of, government officials, contractors that have to do the job. And then there's us that sort of have to be the ones either designing the work, or how we can coordinate and facilitate the work being done while the train is still pretty much running at full service 24/7. So that can definitely get difficult at times. But for us as engineers, we try to stay really sharp and positive to the end goal. And our number one objective is, of course, to be safe along each construction project. So that's sort of our main priority, is to obviously keep the work zone as safe as possible, but to also get the job done at a timely manner for, in this case, CTA, or in Mike's case, CDOT or IDOT. These pictures, you can see, I mean, like I said, it's 5-story buildings that are literally like 6 feet away from the train tracks. So it can definitely get, a little chaotic. But us as engineers, we like to stay as mellow and, like I said, as sharp and, really positive as possible. Even through the chaotic times of, let's say, there's a delay in the train, which obviously we don't want. but it happened. You know, we try to be on top of what mistakes can lie ahead. We try to sort of, you know, really, you know, stay ahead, like I said, just to, you know, be prepared for anything that is to come when all this construction happens along each train track.
Hello.
So that's
Hello, West Park Academy. My name is Patrick Laux, and I'm part of the Bridge Group here in with WSP Chicago. So I work on designing repairs for new and existing bridges. I'm a consulting engineer, and I'm originally from Wisconsin, actually. I went to the University of Wisconsin-Madison. That's a couple hours away from here. And then I later studied at the Illinois Institute of Technology, IIT, on the south side. So I've been with WSP working as a bridge engineer now for 9 years. And I've been working a total of 15 years. So been doing a lot of bridge design. It's really my passion. Some of my advice for the students listening in is that it's okay and it's normal to feel unsure about how could I become an engineer, an architect, or one of the fields in STEAM. When I was growing up, I didn't know an engineer in my family or any friends. And it wasn't until I was in high school that I met a friend from church who was an engineer. And I was able to learn a little bit more about her path and how she became an engineer. So, you know, it's okay to feel like this is, you know, how am I going to do this? And even us now, when we're working as engineers, sometimes we feel nervous about stepping up to the next level in our jobs as well. So that's my first advice. And I'll tell you a little bit more about my background. You go to the next slide, Mike. So before I was working at WSP, I actually lived on the East Coast in Northern Virginia, and I was able to design some really cool bridges out there. One of them is pictured in the photo on the left. So I worked there for almost 4 years. This was a big ramp structure I helped out on. It was a new highway. I also worked in a different area for a little bit. I stopped doing bridge engineering, and I worked in the United States Peace Corps for 2 years. And I was in Central America in Honduras. So I spent 2 years working on water and sanitation projects and doing engineering there. So if you flip to the next slide. So you can see as an engineer that, you know, we learn as civil engineers a lot of different things. Fortunately for me, I was able to spend those 2 years helping people in rural areas, improve their water system, make it safer, make it healthier. I fortunately got to work on a really cool project in the mountains where we built a water filtration plant. You can see in the upper left. It was a really great experience for me. I really liked working with the people there, and it was great, just in a beautiful country too. So I was really lucky to be able to do that. And the next one. So now I'm going to share a few of my favorite projects. These are some projects in and around Chicago. I also have had the benefit of getting to work with Michelangelo too on the Wells Wentworth project that he showed before. So we do get to work with other groups. And here I'm going to show you the bridge over the Chicago River. Some of you may have even been over this one. And I also know that I saw that your teachers had you do some projects recently building bridges. And I was able to scroll through your photos, and I saw some really cool designs. I saw Truss Bridges, and that's what we're seeing here at Webster. You can see in the formation. This is actually a movable bridge, and Chicago is home to over 40 movable bridges. Some of you may not have even known that. It's one of the cities with the most movable bridges in the United States. This bridge had new decks, new beams, and they're actually rebuilding these bridge houses. Can you flip forward, Mike? This is another project. This is in downtown Chicago, just west and southwest of the downtown part. This is what was used to be called the Circle Interchange is now called the Jane Byrne Interchange. And we were working on this project, replacing the old bridges as part of the construction. And this project's been going on for a very long time. It takes a long time to replace these bridges. So you can see in this photo, they're rebuilding the bridges. There's some girders you can see here. So this was a girder bridge. I know some of you designed beam bridges in your projects. So this is an example of one of those, except it's on a curve. And then here's another one. This has been a really cool project for us. This is part of the Lakefront Trail. So when you get over by Lake Michigan, some of you guys have probably gone with your families over to the lakefront. There's a trail that runs from the north side to the south side and back. And when you cross over the mouth of the river, there's a movable bridge there too. So WSB was responsible for widening the trail and working on repairing the bridge. So you can see in this photo here, there's a bit of work happening onto the bridge where we created an opening in the bridge house, and it's soon to be finished this year, which we're excited about. Next slide, Mike. And then lastly, this is another project that's really a dream project for an engineer like me. This is called the Utica Bridge, and there's two bridges in this photo you see. One is a truss bridge, and that's in the background, and that's an old bridge, and it's in very bad shape. So WSP was asked to replace that bridge with a new design, and so you can see in the lower picture there's a graphic, and that's what we came up with in the early phases. It almost looks like a video game. So we designed this, and we made sure that it had enough clearance so ships can get through. And then later we sent out a person to take some pictures with a drone. So that's what you see in the upper left. And this bridge is really long. It has a 440-foot main span. So for us, that's about about as cool as it gets. Although it's not a suspension bridge, but pretty neat. Okay. Next one, Mike. So just as I mentioned, I've been fortunate to work on some movable bridges, and I want to show you, the three main types that exist. I think it's they're pretty neat. There's three types, and we think of them by how they move. So there's something called a Bascule Bridge, or you can think of a drawbridge at like a castle, and that's going to move up and down, rotating. Okay. And then in the middle, you have something called a lift bridge, and this one just moves up and down. And then the last one is called a swing bridge, and as you can kind of guess by the name swing, it rotates kind of like a door. So it's rotating about the vertical way. Okay, Mike, next page. Yeah, so here you can see this is kind of showing some of the engineering behind it. These Bascule bridges, as they go up, these are what we have here in Chicago, all downtown. And you may think that it only has one arm over the river, but there's actually an arm behind it that has a counterweight. So that helps it lift it up in a balanced fashion. Next one, Mike. This is a bridge in Florida that some of my colleagues worked on before I started at WSB. This was rebuilt. It's called the Johns Pass Bridge in Florida. Okay. This is another example of the second type, the lift bridge. And to make these lift bridges work, you need to have two towers. So, and on those towers, you keep a counterweight, those red boxes, and that's filled with very heavy material. This is kind of a similar way an elevator works. And so as the motors turn, they lift the whole bridge up into the air, and the counterweights go down, offsetting that weight. Okay, next photo. And then lastly is the swing bridge again, and this is interesting because when it sits on its supports, the trucks can pass over it and it works just fine. But then as they start to rotate it, it cantilevers. It's going to balance forward and back by the way it's designed here. So it's a really neat bridge. We don't have very many of them in Chicago, but there are quite a few in the United States. And I think, oh yes, and of course there are some other very cool types of movable bridges. Here's a couple shown I like a lot. You can see the one in red. It's kind of like an accordion. It opens up. Then you have a rolling bridge in the right. And then I think that last one on the bottom is in London, which is really cool. So that bridge rotates as well. So I hope you like that. I really like those designs I was seeing the students make, and keep it up. And I think that it's a great thing to, bridges are pretty cool. And now you'll hear about buildings.
I just wanted to share one last cool video on a bridge. It's a time lapse on a downtown bridge where There's train traffic up top, car, people, and bicycle traffic in the middle, and then boat traffic underneath. It basically did everything except airplanes. So this is how they rebuilt the bridge within 9 days, so they can shut down traffic of the CTA up at the top level of the bridge. So you can see all the boat barges bringing material, a continuous cycle of day and night of working. And luckily, the service was able to be granted back to the CTA with no issues. It's pretty cool. You never notice when you're driving by at night, people are still working. And there you go. You see some trains up top. That's it. All right. Well, take it away, Alex.
Okay, can everyone see my screen? No, you cannot. Yes, you can.
I could see you.
No, her, but
my screen.
Yeah, there you go.
Oh, there you go.
How's that? Good. Hi, everyone. My name is Alex. I'm a structural engineer, but unlike Patrick, I work on buildings and he works on bridges. I grew up in the Chicagoland area, and I went to school in Indiana for my undergrad, and then I also got my master's in California. And I've been working for 2 years, and my best advice is to apply for every opportunity available, even if you think that you're not good enough or you're not qualified, because everyone thinks that they're not qualified, but someone has to win that award and someone has to get that job, and it could be you. So who knows what architecture is, right? So architecture is the practice of building and designing buildings. So we have tons of different types of architecture, right? We have houses, theaters like Sydney Opera House, museums, schools, and we have tall buildings. That's my specialty, is the tall buildings, like this, like what's this called? One World Trade Center in New York, and this is an office building. So so then what's my job? I work with architects, and if you imagine a building is like a body, like your very own body, what part am I designing? I'm designing the skeleton. Okay, so if you didn't have any bones in your body, you just be a pile of skin, muscles, your organs, you wouldn't stand up. And so my job is to design this skeleton so that you can move, everything's safe inside. So when you are, I'm sure you guys have at least seen houses, and I'm sure if you've ever looked out at the skyline, you can see tall buildings in the distance, because we're Chicago and we have a ton of tall buildings, and you see them from the outside, like this Empire State Building with, I think, King Kong on it. But what's happening? Why is this building able to hold King Kong? Well, the reason is that on the inside, there's this whole puzzle of like little bones holding the building up. So up here is what the inside of the Empire State Building looks like. And so why do buildings stand? They stand because they have columns and walls and floors and beams, and just like bridges have all of their, trusses and stuff, buildings have that too. And so that's my job and that's my responsibility. So, and what's the biggest responsibility is life safety. So for all of our projects as a civil engineer, we want to make sure that people are safe, right? So I have my little skeleton guy, another little skeleton guy, and we don't want this to happen. And fortunately, this doesn't happen because our jobs, that's our job, is to make sure that buildings don't fall down. And then also, what's really cool about structural engineering for buildings is and for all structural engineering, is we push the limits, right? So we make the impossible possible. An architect says they want to build a building that's half a mile into the sky. We say, okay, we'll try. No, but actually we do. So the Burj Khalifa is the tallest building in the world. It's 2,700 feet. So if you live in a one-story house, your house is maybe 15 feet tall. 2 stories, maybe 30 feet tall. So this is about 100 to 200 of your houses stacked on top of each other. We also push the limits of how skinny we can make our buildings, right? So this is So this is a building in New York City, and you can see it looks like someone just stuck a toothpick in the ground. It's so skinny, right? But someone's going to be living on the top of that building, and so we need to make sure that it's a-okay. And then, finally, a cool example from Chicago is 135 North Riverside. So if you look down here at the bottom, it looks pretty odd for a building. It's really skinny on the bottom. So if you look at that from the street view when it's being built, I mean, who's ever seen a building skinnier on the bottom than the top? Pretty unusual, but this is structural engineers made this happen. So an architect tells me, hey, I want to build a building that's gonna be an office building, and maybe we brainstorm on what materials we should use. So we can build out of steel, concrete, bricks, and wood. And they each have their pros and cons. But one of the things that you learn in school is you learn how to design with each of these materials. How is this one gonna work? How is this one gonna work? Because they all work differently. And then when the architect tells us, okay, I want, say in this case, it's a house, or we can say a building. What do we design for? What am I actually calculating? I'm making sure that it can hold everything it needs to. So first of all, it needs to hold itself. And then it needs to hold the lights in your house. It needs to hold the roof. It needs to hold a bunch of stuff like that. You might have, if you have a basement, you might have pressure coming in from the walls below. You also have to hold yourself, right? You want to be able to know that if you have a party with you and all your friends, that if you're all sitting in the same spot, you'll still be a-okay. Maybe some snow. We get a lot of snow in Chicago. You don't want your roof to cave in. And then a big one in Chicago is wind, and that's a big thing that for people designing tall buildings, you get pretty windy up there, and we don't want the people. Do you guys recognize this? This is the Sears Tower. Or Willis Tower, and there's people that work all the way on the top there, and if their building's moving too much, I don't know. I know some people like roller coasters and moving around, but I get really sick, and so as a structural engineer, it's our job to make sure that if someone's in a tall building, they're not going to get sick. And finally, we don't have to worry about this in Chicago, but the last thing is earthquakes. So if you lived in California, the ground shakes sometimes, and we don't want our building to fall down like that. So we also have to make sure that you're safe from earthquakes too. So how do we do our job? What am I doing during my day? Well, so you can see here's like a picture of kind of what Patrick was saying about it kind of looks like a video game. This is, say, an idea of a building that an architect wants. First half is we have to build a full model, a computer model of the skeleton of the building, of the structure, what we're designing, because we want to test it on our computer. We want to put some wind on it. We want to shake it a bit with an earthquake. We want to make sure that it's okay as a whole, right? And then we also need to design each little component. So I need to design, so maybe the floor here is holding, just an apartment, and maybe over here it's holding a gym, right? So there's going to be 2 different designs, or maybe, the way I design floors is going to be different than the way I design columns. And so the one thing that I think is so cool about my job is I actually use the things I learned in school, starting from your age up through college. I still use a calculator. I still use math. I need to know physics. And I really like that about my job. I use what I learned in school every single day. And so you can see here we use spreadsheets, different programs to design components. And so eventually, hopefully, you've designed every single component of a building. So finally, so this is actually, I want to show a project that I'm working on. This is a project in Minneapolis, and it's an apartment building here, where my mouse is, and it's connected to an office building. What's really cool is if you guys have, if you follow baseball, the MLB, this stadium here is Target Field, where the Twins play in Minnesota. So these people up here are going to have some pretty cool views inside the park. It'd be like, if you want, you could just get home every day and watch the Sox play or the Cubs or whoever you root for. So it's pretty cool. So this is what this is what it'll finally look like. And this side is what I'm designing with my team, is the skeleton. So I'm on the design side, right? Eventually this building has to get built. Eventually we need people like Michelangelo and Gabe to actually figure out how to build the thing. That's not my job. My job is to just make sure that they know what has to be there. So how do we do that? Well, back in the day before computers, you would literally have people whose jobs it was to draw every single component of the building. So when you see old buildings downtown that are even 20 stories, there was someone who had to draw every single part of that building so that it could be built. Something called blueprints. They would make blueprints. They would have their huge drafting tables and they would make blueprints. Super cool. Well, so thank God we don't have to do that anymore because we have computers. So,
Yeah,
okay. So now instead of drafting, we have programs that help you do it. So we are able to model the whole building in 3D. So I can walk around my building. This is literally what I'm working on today. This will be one in Chicago. And then we can draw instead of, say, instead of drawing all this by hand, we have it by computer. So we can, move lines or, change shapes of things. And then eventually this gets printed out and Mike or Gabe take it and they build it. So so that's about kind of like the process that I go through every day. And my final thing that I'm delivering that someone's asked me to do is this whole big set of drawings for the whole building. My final slide is what my favorite thing to design is, which is structural components, so columns and beams and ceilings, but as the architecture. So when the coolest part of the place you're walking through, if you look here, like you'll walk into this lobby and see this awesome, almost sculpture. But what that is that's actually the columns holding up the whole building above it. So we get to design something like that. Or this airport, you see this awesome, columns and this swooping roof, and that's actually the structure. We get to do that, even though it is very, architectural. And the last one is the most prime example of that in Chicago is the John Hancock, where you can see these X's, right? And if you rotate this, doesn't it look like kind of some of the bridges? How you have the truss? It's almost like a bridge turned on its side. Pretty cool. So yeah, that's the end of my presentation.
Alex, let me ask you a quick question while you've got that up. We learned in third grade and fourth grade, we were talking about skyscrapers, and some of the buildings have like a hole in them so that they don't
Yeah.
swing as much. Do you know what that's like? Maybe there's a better term for that?
Yeah, so we call that a blow-through floor, and it's because the air can blow through it. So, so let me see. So I'm guessing you were talking about something like this. So this floor here is actually open, right? And so, because look at how skinny this guy is. This is a pretty skinny top here. And so if the wind were to push on it, it might move a lot. So we leave this floor open so that the wind can just go right through it and it doesn't push on the building. Does that answer your question?
Yes, yes, thank you.
I'm sure it's also just a level to get some air after a stressful day.
Yeah, I wonder if they let people on those floors.
I'm not sure.
I wonder if the elevator stops at that floor. Like that would actually be kind of cool to get that outdoor space in the middle of like way up there, and the view would be amazing.
Yeah.
Yeah, this is awesome. We're hoping next year to have some field trips to the Willis Tower and things like that, where the kids can go downtown and really see the architectures, closer. I was wondering if you could, maybe anybody could chime in. Did you go to, like, I know you mentioned you all went to college. Did you go to like a 4-year college? Did you do anything to prepare, like, make sure that the college had the type of courses you wanted to go to? Anything about like how you planned, like, I want to be an engineer, and what you went through to get to that point?
I could go. It's similar to, I think, maybe a lot of stories. I was good at math and didn't know how to apply it. So I think having someone to help you where to start is key. Because being good at math and science is, where do you go from there? And I think taking advantage of all the opportunities around you can help guide you to what you would be looking for in a school, say a high school and then college. So when you get into high school, I think a lot of those opportunities will start embracing more. But even earlier on, there's a lot of extracurricular activities that can help guide you to say what school would be great for what you want to learn. Some of those programs might be involved within your school, say in general, like an engineering club or projects. And some may even be outside of school, like one of them is called ACE, that actually Alex is a mentor in that program, where you get to learn about architecture, construction, and engineering. And I think the key thing too is, from being from Chicago, some really good schools that are for engineering are IIT that Patrick has went to, University of Illinois Champaign, and then any other schools like for civil engineering within Illinois area, but also outside of Illinois would be a really good experience as well. Gabe, Patrick, do you have any other things to say?
Well, I would just, so all 4 of us did do a 4-year college.
Yeah, I've seen someone say like joining a STEM team, but go ahead.
Mm-hmm. Yep, and there's also, I think, I'm not sure if you've heard of Future Cities. That's a way to apply some math and science as well. A lot of the larger schools have engineering departments or engineering schools, they're called. So if you're interested in a particular area, when you get to high school, you'll have a chance to do college visits and look for schools that have programs that interest you. You may not know until you're there and studying as well.
Yeah, and I'll add one more thing. I actually applied to colleges thinking that I wanted to be an architect. And my senior year, I took AP Physics, and I had always loved math, and I didn't even know that structural engineering was a thing. And so I said, I got to school, or, it was before I was going to start, and I said, oh, actually, I think I want to be a civil engineer so I can become a structural engineer. And so I think one of my tips would be, even if you think you know what you want, make sure that when you're going to school, A, you keep your mind open, but B, that your school has, you know, maybe multiple things that you like, because you might start, what if I had said, oh, shoot, I want to be a civil engineer, but the school I went to only had architecture, you know, that would stink. So I think it's important to, you know, make sure your options are, you have a lot of them.
Alex,
with the
on that
solution.
same note, did you ever run into anything? I mean, women are not a common occurrence in the engineering field. You know, I'm wondering if that was ever an issue for you, if you find it challenging to be in that career choice.
There are certainly challenging aspects to that. Actually, in school for civil engineering, it's fairly equal. I think when, you know, if you were to perchance say like mechanical engineering or computer software is a bit slower behind, but, you know, I think really the best thing is having other female mentors, or, you know, you have Dr. Rose here like teaching you about this stuff. I think when you see, you know, and try and befriend the women around you in your program, that really helps, and that really, it makes you feel less alone. Because yeah, I mean, sometimes you're in a 5-person project and you're the only girl, but you know, it's really fun, and you're, you know, as a woman, you're just as smart, if not smarter, than the guys, so you'll be okay.
Awesome, thank you. If anybody else has any questions, I think, or anything else to say, I think we can wrap it up. Ms. Ossoff joined us. This is our principal at our West Park Academy.
Good afternoon. Thank you so much for this amazing presentation. You do not know if you today, by sharing, woke up the engineer and a few students in our school. I think that you saw the presentations of the bridges, and you know that Dr. Rose is working very hard to keep the STEAM dream alive for us. And she's a firm believer that all of our students need to start thinking, dreaming, and expecting a bright future, engaged in what they're passionate about. And you guys were wonderful with your presentation. Thank you also, Mr. Pineda, for creating this connection for us. This was a super treat. Thank you so much.
Thank you, Principal Assad. Thank you, Dr. Rose. Thank you for having us.
Thank you so much. Actually, the local high school that's closest to our elementary school, North Grand, they offer an engineering program, a pre-engineering program. So some of their courses lead into colleges, and they help kids connect into the engineering field. So we're hoping in future years to make that connection from the STEAM classes into North Grand High School and then beyond. So hopefully we have some young budding engineers watching, and we'll put some more people in the field. Thank you so much. We really appreciate your time and you know, taking time out of your busy day to help us with this.